Hey guys,
Hey
can
there.
you hear me? And can you see me? That's what the seeing part I think just starting up. So you should see me now. Hello? No, not yet. Hi, you see it? Okay, I think you should see me now. So today is what day of the week is today? Let me check. Completely get lost because that's how I am. Very, very short memory. So let me let me quickly check the it's Monday. Okay, I see. And what I'm going to do is recap with what we discussed the previous time, which was Friday, I guess, and move forward from that point onwards. So let's see who is here. And 4 people: Brian, James, Mark, Tammy. Hey guys. Uh, I guess we will start. We will, not wait for people to join. They will come whenever they can. So I think we last time when we started discussing this, I suggested that you read this book on your own, which I'm assuming that you will read. It is not a required reading at all, but it is a very good book. It is. I expect you to read, and so read that at some point. It is going to help you in general, not just with this cloud computing thing, but it's a good book to have read. And let me just make a do not disturb thing here, like that. Otherwise, we keep getting notifications. So that was the book mentioned that I had. The other thing we started discussing was some of the tools that we use in the context of enabling end-to-end service delivery to our customers. And one of the tools that I think we started playing with was Chef. And so I want to make sure that I'm projecting my desktop. I am. And we started playing with this thing called the Chef First Run. And I would like to draw some parallels with this run that we did. And so this was the Chef run we did first time using, there are 2 modes of operation. One is the solo mode. The other one is a client and server mode of operation. So we've practiced with this. We will practice with this as well. But I'm going to just give you a comparison of this tool versus this tool. And there are so many tools out there that it can be a daunting effort to just practice and learn all of them. So my suggestion would be to understand the pros and cons of these tools as we go along and pick 1 or 2 maybe that suits your purpose, your project that you might have in your mind, or your company may be using 1 or 2 or more such tools. So you need to basically focus your energy and don't distribute them across the board everywhere, which doesn't actually help. That's one way to think about, should I use this or should I use that tool? So there are pros and cons of using these tools as we will use them. But a couple of things that you should remember is this comparison that I'm going to quickly give you, which I think I briefly mentioned. This is based on, Chef is based on Ruby as a language. And this Ansible thing is based on Python as a language. So people who like Python tend to use this. People who like Ruby tend to use this. I think Brian, who is right now on the video conference, likes to use Puppet. And so Puppet is also kind of sort of like almost like Ruby. There are some variations to it. It is not strictly Ruby, but it is in the same game, same ballpark. So that's how you can decide whether the language of choice dictates the selection of the tool. But I think that is a wrong way to think about picking a tool is what you already know and then you extend. That's the easy way of doing a selection. The right way to think about is, what does the customer need? What do they need solved? And how does the tool help solve that problem? And that is, I think, the more appropriate way of looking at picking a tool, selecting a tool from the customer's point of view. It is not about you. It is not about the language you know. It is not at all about anything to do with you as such. It's all about the customer as to what they want. So that's how you should always think about, customer can mean employer. Customer can mean client. Customer can mean your consulting partner, whatever that means. The person who receives benefit by you doing something, I generally call them customers. Like you work for a company, the company is your customer. They pay you for your services, for your time. things like that. So with that quickly said, I would like to identify some of the key differences between how these tools work. The model of operation that you saw in case of Chef was these two different models, the solo mode and the Chef client server mode, client plus server. This is a fairly elaborate tool. It has been in place for, I think, close to 7 or 8 years now. And so about that much time. This is a relatively new tool. Relatively speaking, it's only a couple of years, relatively new. I will also tell you the way I like to use these tools. I don't limit myself to just one or the other. I actually mix and match. Depending on what I need. I will add components and go around using these tools. Like currently, the way I like to I prefer using Ansible to do basic system administration tasks, like fix this, fix that, and get those things taken care of. Put this configuration file in that location. Those kind of activities I tend to use Ansible quite a bit for primarily around system administration and upkeep tasks, which can be automated through Ansible. This Chef tool is fairly elaborate in terms of how it applies to setting up a configuration for a given service that you want to deploy for a given customer. So we will like to actually go deeper with one of these two tools and play some, as we go along, play similar examples of Ansible as to how we can accomplish what we will try to do with Chef as well. So if you look at this set of exercises, you will find that there are a lot of things written down for Chef, but not much written down for Ansible, because Ansible is a new player and also a new participant in our bootcamp. So we don't have too much written down, but there are some exercises that I already have in GitHub. I will be pulling it from there as we go along. This write-up that you see here, like we are going to practice these things as we run the video conference and the bootcamp. We will follow this from Chef perspective, and we'll go to GitHub from Ansible perspective. That's how I would like to make sure that you understand. The other thing that I want to do is helping you comprehend this Chef tool in form of exercises. The reason I do it that way is because if you go to this location, which is docs.chef.io, the documentation is available, but it's not user-friendly, and it doesn't tell us how and what these things mean. So what I would like to do in the exercise for today is to help us understand what that components are, and we'll always refer to the documentation as we go along here. But the exercises here are designed to help us understand what that documentation can do for us. We'll do similar things for Ansible also. Ansible has extensive documentation as well. You can see Ansible documentation, and that is also published right here. And we will focus on the Ansible core portion, which is the open source pieces right there. That's what we like to focus on. It has also beautifully written down documentation. And what I will do is, as I introduce you to details behind Chef, I will attempt to give you similar analogies of the Ansible story as well, so that you can comprehend both tools as we go along and practice whichever one that you like to use. Having said, what I want to do now is begin this discussion around using Chef in solo mode to begin with, for which we, of course, need that virtual machine which is starting up. In that VM, we will run these exercises, which are, in that VM we'll run these exercises. The exercises are not super complex. They're very simple to begin with. They'll go increasingly complex as we proceed through these exercises sets. Now, back in our exercise that we have written down for using Chef in solo mode, our goal is to make sure that we understand the concept. The end goal of this particular exercise, let's see what it is. Let me get to the end of the idea. Okay, the end goal with this particular exercise is in this segment, which I'm going to give you a link in Slack chat right there. It begins at that point. And that exercise, the end goal of that exercise is what I would like to elaborate and describe. And it is going to be pasted in Slack chat in just a sec. And the end goal is like this with the Chef solo exercise that we are about to begin. is at the end of the game, I would like to have some machine running as a database server. And it needs to use my chosen password. Whatever I choose as my password for the root user in that database server. That's what I would like to have the outcome. So it's a simple exercise from that perspective. But the idea is you can accomplish the same exercise with a few lines of code. They're not automated though. The problem with that exercise will be that you cannot choose your own password. You have to choose a password that you like for your example, for your exercise, for your scenario, for your customer, and automate that. That's the complexity here that Chef will help us. You can install a database server fairly easily with like 2 lines of code, maybe 1. That part is fairly easy to do, but the part that is not so easy, or rather non-trivial, is to make sure that you can actually do it like this: sudo apt get install, and then you can say install MySQL server. This should do it. I mean, that's pretty much it. I type my password, and I proceed. So this installs MySQL server. And I'll say, do you want to continue? I'll say yes. And it will install a complete database server for me on this machine. However, as a challenge that you're looking at is in your face right now, the challenge is, give me a root password, please. It is asking you, it is prompting you to give me a root password. That step is manual. I don't want to do it like this because I will be setting up like 1,000 MySQL database servers, for example, just making it up. I don't want to be typing this my chosen root password for the root user in that database server 1,000 times. I want to automate it. So I can actually type something like here and say, okay, repeat my password, and off it goes. And it sets up a database server, just like you see. And now database server is running on that VM. By the way, this was pointless, just a demo to tell you that there is this mechanical step needed, which is manual, and I want to cut that down. I want to do it the chef way. The chef way would be that you define your concept, your idea. Like, what is my idea, my result? I will write that down in a folder, and I call this my outcome, my desire, or whatever I have. Like, you can call it whatever you like. Maybe some people call it idea. Basically, it is a Git repository. It's a folder that contains things that I will like to have. And I will apply this design that I have in mind on a bare bones, just enough operating system, which I refer to as an embryo, which is not technically accurate. But that's what a just enough operating system I would like to get, and apply this design, and I should get my result, my outcome. My outcome is I want a database server with my chosen password in place. That's what I would like to have. And I would like to have this repeated like 1,000 times, 100,000 times, whatever the need. That kind of automation is what I would like to build. And I will be using that exercise example in the link, which is available in Slack chat right. Where is that? Come on, right there. That's the link. That's what I will be beginning from. And I will be using a machine in the cloud to make this thing happen. I'll basically get a machine out in the cloud, say some cloud, just enough operating system, just plain vanilla Ubuntu Linux or some other Linux. But just get an OS and run this chef idea using the chef solo mode and make things happen, get the result accomplished, and feel happy about it. That's what this exercise is about. Now, to get to that point, we have to build certain components. We have to build certain, what I call folders in that Git repository, right? You saw this Git repository. We have to write things down in a folder and call it our design, call it our desire, chef repo, whatever names you can choose to call this thing. That's what we are beginning to construct. Now, inside that Git repo will be several folders. Each folder will have a specific meaning to it. For example, the last time, if you remember, we did this ready-made example. And in there, we had Atom Editor open. You can see that it has a bunch of things already in there. You will see that there is a cookbooks folder right there. And this local mode cache, you can just delete it. It's not really relevant. So I'm deleting it. it apparently cannot be deleted because of the permissions issue. So I'm not deleting it. I'll delete it later. I'll just hide it from view. There is a folder called nodes folder. This folder also contains information about the nodes that I will be using in my cloud. So I need to help you understand what these things mean. The cookbook folder, the nodes folder, the DNA JSON, then solo RB, and there will be more such things as we begin expanding our scope. So this example, we are not really using, so I'm going to quit this example out. Instead, come out of this and prepare a new folder. And in that folder, we will be working with Chef Solo to understand all these elements inside that folder. What do they mean? How do we make use of them to accomplish a goal, a desire that we might have for ourselves for a project? That's the idea. Now we'll begin doing that. And so we will quickly read. What does this say? That we'll be doing chef by example. So we'll proceed next step. And then here, we'll prepare our kitchen foundation. And there'll be more kitchen-y names like cookbooks and kitchen, and everything to do with cooking will be showing up here. So we have to create a foundation for the kitchen. Basically means create a folder. What do I do? mkdir my cloud is the name I chose. So here, I created a folder. I go inside it. Now I have that folder called my cloud right there. I will open up Atom Editor and it is empty, expected to be empty. And so that's my empty folder. I will leave it aside here. And I will then do something in there. That thing that I'm doing is going to create a file called gem file. Now this gem file is all about discipline. Discipline of teamwork, making sure that everybody is on the same page, making sure that everybody follows the same set of rules that we set for ourselves. So we have to create a new file here and call it capital G, gem file. Gem file. This gem file basically is a list of things that I need for my project, for this project. So it's basically a specification that I need to get these things from this location. So I'm saying out that please get me these things from these locations. Which location? That's the location, the Ruby Gems location. That location stores all these ready-made gems, ready-made software prepared by a bunch of people who are passionate about creating Ruby software. They create gems on rubygems.org. You know this already from the last couple of times. So that's the location I want my tool to go and grab these gems. I'm very specific about what versions that I want, and I'm writing that down in this file called gem file. And I saved it so that I have that first file in my folder. That's the way to ensure discipline. Now, in other languages, there are similar methods. In Python, there is a thing called requirements.txt Python that helps you accomplish the same thing. There you can see how to use. So yeah, let me identify a good place to read about it. Maybe this one is a good one. Yeah, that Stack Overflow should describe what to do with a requirement.txt file. It's pretty similar in construct. Like get these things for me in my Python project. So that's requirements definition. You define it. I need beautiful soup, Django, Fabric, Jinja, this, that, drum version numbers called out. And these things come down to a Python project from a central location called PyP or PyPy. That's the location where it comes from. This is the Python package index. You can download any package from Python package from this site, just like Ruby Gems for Ruby, PyPy for Python. And every language, every community has a site like this. They will put together stuff in one common place so everybody can share. That's about Python requirement.txt. Now back to what we are doing, which is right now using a gem file. This is the gem file. So what I want to do now is ask Ruby to please go get these things for me. Right? That's what I'm going to do. In my command line, I'll say, hey, Ruby, go get these things, these gems for me from that location, number one, line number one. So how do I do that? I'll say bundle, or to be specific, bundle install. I don't have to type the word install specifically, explicitly. I can just say bundle, that's good enough. But I'm going to say bundle, please install these things for me. So here we go. So now what will bundle do? is go to that location specified in line number 1 and download all these things, put that in the right location. Now, what is that right location? It depends on the machine configuration. The location will be where Ruby is supposed to store its gems. That's the location. So now we have those gems already in our current location. We are using the version of Ruby-V is 2.3.1. That's the version I have installed. Your Ruby version may vary. Two of you Linux users right now, you need to make sure that you understand what you're doing with Ruby. You need to understand, so just a side break for you guys. I suggest for both Linux guys and those who are going to venture out and running your own Ruby, use this tool. This is a good tool to manage multiple Ruby versions on the same box at the same time. For different projects, you can get different Ruby versions. The project is RBENV. I have it installed already in the virtual machine, so you don't have to worry about it. But since some of you want to, here we go. That's how you do RBENV. So install any Ruby version you want, all the versions you like at the same time in the same machine. Use only one at a time for a given project. That's how you do it for Ruby. Similarly, there is a way to do the same thing called virtual ENV for Python. So you go to this location, read about it, and set it up on your Linux boxes. How to do same thing on Python. So you can get Python 3, Python 2, Python 2 point whatever, 3 point whatever. Mix and match. Don't cause conflicts. Be careful. Don't mess your machine. Read it very carefully. These are tools that you need to really understand before you use them. But for right now, just stick to the virtual machine. Don't mess with it. Don't mess with your machines, please. If you want to mess, do a one-on-one with me before you mess. Having said, this machine has 2.3.1 loaded. And yes, we are using RBENV. RBENV, you can see versions installed, and we have only one. And that's the version 2.3.1 set by the RBENV software. So we have this Ruby version specifically for our group project that we are doing together. And we have said, Ruby, please go get me those gems that I have specified in my gem file. So Ruby did exactly that. Our bundle exactly did just that. And what it did was, let's go grab and look at what it just did. What it did is created a lock file. This lock, gemfile.lock, was generated as a consequence of me running a bundle install. And this is a dependency map. It basically is a matrix of cross dependencies. This depends on that version, and that depends on this version, and that dependency matrix is called out right here, multiple lines. You can see how each gem is dependent on other gems. So like, for example, knife solo gem, the one we wanted, 060, it depends on chef needs to be more than version 10.20 and eRubies and net SSH, like that. So we have defined the dependency structures. This file is automatically generated. It is a lock file. You need to make sure that this gem file, even you bundle install this, it installs those gems in your computer and prepares this lock file. So you should put these two files together in your version control, Git repository, for example. Having said, next step, what I want to do is, when I say bundle, I think it's too small. So I'm going to expand it. So I installed these gems that I wanted. Next, what I want you to do is, we have installed a new tool, by the way, in that gem file. That tool was Knife. This is the tool that I just installed through that bundle install step. So Knife is another chef tool that helps us do what? It helps us operate on random machines out in the cloud. So C1, this is some cloud from some company. This is another cloud, C2. And so we are here, and we have our laptop. And here is where we will run our Knife tool. This runs here, And what it does is effectively remote executes chef, remote exec chef client, or a chef solo, any of those two ways of operating on the machines M1, M2, M3, any number of those you have in cloud number C1, C2, like that. So it's a remote execution tool that we want Chef to run over there, out there in the cloud, or maybe there is this garage that you have. So in the garage, you have some machines, M1, M2, M3, like that. So it will also run just like that. So it should be able to operate on any target. The goal here is to do remote executions of Chef. That's the primary motivation behind the tool called Knife. We are going to be cooks. I mean, yeah, I have to use the phrase and the cooking analogies too. So we are the cook. We use the Knife tool to remotely execute Chef commands on the remote target machines, either in the garage or in cloud number 2 or cloud number 1, like that. That's the goal. So this remote execution tool is what we just installed in our laptop. Here, right there, that's the tool. And now I want to use this tool to do a bunch of things. What am I doing? I will first of all understand what the tool can do for me, and then fill up my repository, like this repository that I have only 2 files right now, gem file and gemfile.lock. I want to fill it up with a bunch of things. How do I do that? I use the tool to do my business. So I will say, you know what, Chef, Knife, you create me a repository. You create me a kitchen containing all the things that I need for my Chef project. So you please help me. And so that is what I will do to this tool. I'll make use of that tool to do these things. What that tool we are talking about, Knife tool. It does 5 things. One of the things is init. It initializes a kitchen, initializes a repository, initializes a folder, basically fills it up with stuff we need, like a template. That's the initialization step. There are 4 more things to do, which are prepare, cook, and bootstrap and clean. So prepare, cook, bootstrap, and clean. Prepare. So let's see what these things do. The first one, initializes your local folder. So we'll see that in action to understand it very quickly. It's a very simple thing, just initializes a bunch of things for us. Prepare is an action which basically happens on the remote machine. On the remote machine, when you say prepare something, Knife prepare this, Knife prepare that, what it will do is install Chef on the remote machine. When you say cook, Knife, please cook, it will run Chef on the remote machine. That's the action expected when you say cook. Prepare will install Chef on the remote machine, because most machines will be like just enough operating system. They don't even have Chef. So first thing you have to prepare, meaning install the Chef software on the remote target machines, cloud 1, cloud 2, machines 1, 3, 4, whatever numbers, any number of them. So it will prepare, meaning it will basically install Chef. And cook means it will actually execute Chef for you. So it will cook the food for you. Bootstrap. Bootstrap is a command which is a combination of prepare plus cook. It's a simple command, one after the other. First you prepare and then you cook together in one shot. Simple combination command. And the last one is to remove whatever we did. And I never use it. You can use it, but I never use it because I believe in being a cowboy, shooting the machines and moving on. Who has time to clean up and just shoot the machine, get rid of it, get a new one and start again? That's a whole lot easier. That's how I use this structure. You will see me do this all the time. I don't bother about cleaning because I'd rather just terminate the machine, move on. So these are the things. So basically install and run, that's the action. See here, prepare is the install action, cook is the run action. Now let's go screen. Next one. Here, we have these 5 steps defined: init, prepare, cook, bootstrap, and clean. What I'm going to do now is run the init step. How do I run it? You need to, let's see what the next step is before I forget. I think, let's go to the next step. And in there, we will initialize a kitchen. So that's exactly what I'm going to do, is stock up my kitchen with stuff. What stuff I'm talking about? Let's go watch the Atom editor as I fill it up. So what I'm going to do is in the command here in the My Cloud folder, you're looking at the Atom editor. It has 2 files. I will now fill it up with stuff. How do I do that? I'll say basically knife solo, which is the command to execute. I want to execute, and I would say initialize me a kitchen, please, and initialize it right here. That's the command. Knife solo. We are using the solo mode of using knife and chef. So knife solo, initialize the kitchen right here in that location. I can do that. However, I don't want to type it like this. And that is about a concept. So I'm going to break this, by the way, not running it like this. Instead, I will run it like this, bundle exec, and then say knife solo init dot. What was the difference? The difference was about discipline. And I'll tell you what that means. Let's go see, I'll break this also. So I'm going to break it. Now I will say gem list and grep for chef. So I want to see what versions of chef do I have currently installed. And I see that I have 2 versions of chef currently installed. One of them, 12, 21, 14. The other one is 12, 10, 24. Okay, so now is confusion. In my machine, I have 2 versions of chef. Which one will this project use? You have no idea unless you tell it to this machine that I want to use this versus that. There is no way for this project to automatically figure out what do you have in mind. And therefore, the idea of a gem file. The gem file forces that discipline, and we have said bundle install. So when you're executing any step in Ruby language with a bundle exec prefix, it will honor the discipline of making sure that you are using the version that you want, which is called out in your gem file, as opposed to just randomly executing anything you feel like, or it feels like. What does that translate to in action? When I say chef, give me the version that you are going to use, it will give me back chef, I think I should say chef solo. Give me the version number for you, and the version number is 12, 21, 14. This is the version of chef that I used the last time. But I want to make sure that I'm using the version of chef that this particular gem file installed for me. So you know that this gem file installed this version for chef for me, as you know from the dependency map. You can see it in the gem file log if you like. And you can scroll through that and find out. But that's the version that I really want to use for this particular project. So I had to be disciplined about it. And just like I run this command here, say, hey, give me a version number. It says 12, 21, 14. But that's not what I want. I want to run bundle exec. And then say, tell me the version of chef solo that you are going to use when I execute. And it will give me 12, 10, 24. You see the difference? That's what I mean by making sure that everybody on the team that is using a project is going to execute Ruby command with a bundle execution in the command and control by gem file. So we are basically putting a discipline around what we do. So if you prefix any command using the bundle exec prefix like this, it will run whatever that particular project folder contains. And like you can see here, the version of chef that we want to use is the one that is dictated by the gem file. So if you prefix the command with a bundle exec, you will notice that it is honoring that and running the appropriate version of chef. However, if you don't use it like in this example, it just picks up the latest version of chef and moves on. Having done this part, I would like to now uninstall chef version that I have, which is I want to uninstall number 1. And what happens in that case? That I am going to mess up my bundle. So if I uninstall this version, the number 2 version, then I am not messing up my bundle that I have in my gem file specification. So when I do that, I successfully uninstall that particular version, which is a more recent version, which we installed the first time we ran chef. And now if I go and say, chef version, please, it will give me the only version it has got, it failed out because of dependency mismatch. So this might happen to you as well. It is always a good idea to run bundle exec And it will make sure that you are expecting to run the exact version of shell that you intended as dictated by your gem file package list of things that you have. So remember to prefix anything you do in Chef in any exercise with a bundle exec. That's the idea. Now, having said, let us go initialize our kitchen. So here we go, bundle exec, and we'll say knife solo initialize a kitchen right here for me, please, and I enter. So you can see Atom Editor fills it up. Atom Editor has filled up a bunch of things for us, and these are mostly templates. You will also see a bunch of warnings showing up in the command line. You can safely ignore them. It is not critical. You can read them, of course. Read the warning, and it says, you are setting a key that conflicts with the bundle hashy defined in kernel. This can cause unexpected behavior. So basically, this is a warning message given to the people who are using this hashy mash frozen method. It is somebody else. The warning is given to somebody else, not you. You are not the one that is created any software yet. So you can safely ignore these warnings, unless it's an error, in which case it will fail out on you. But apart from this mention, you see that this thing has actually created a bunch of files and folders for you already. Question is welcome.
Yeah, what all the warnings?
So the warnings are generated by the version of Ruby which expects. Let's go run it again. Rather, scroll up to see the warnings. I think we should discuss the warnings. They're a very, very specific thing, like method varia model : attributes defined in hash. You're setting a key that conflicts with. So this is a warning assigned to the people who have those gems for us, that we are using these gems in the gem file. So one of these gems is not up to date, up to the latest requirements of Ruby language 2.3.1. That is what is causing that particular warning. They want people to update these versions of gem file packages in line with the Ruby version. Ruby version we are using is 2.3.1. The gems are slightly older. So here's the Ruby version we have. The gems that we have installed are slightly older, so they do not comply with Ruby's requirements at that point in time. That's the reason of these warnings. Having said, we have a bunch of folders created already in our Atom Editor. You can see them. We started with gem file. We then bundle install to create a gemfile.lock. And then we said, initialize our kitchen, please. And so it gave us a ready-made kitchen. In this kitchen, we have a bunch of folders. Most of them are empty, by the way. Let's go see what we have. So there is a folder called cookbooks. We know that already. It is a place to store cookbooks. We have a folder called data_bags. Another one called environments. Another one called nodes. A folder called roles. A folder called site cookbooks. So what do they mean? And there is another one, by the way, this thing called .chef. It's a hidden folder. And in that .chef folder, which is a hidden folder, is a special file here called knifeRB. It defines some things that you may remember from a previous example of, when I said in a JSON, DNA JSON file, which specifies where are my cookbooks located and what are the other things located, what is my cookbook path. It contains my cookbooks, and there's another folder called site cookbooks, which also contains cookbooks. So what do they mean? Why do we have two of them? There is a folder called nodes, which will contain nodes. And so what are nodes? What are nodes? I have no idea. So let's go understand those things. Here, what we just did is we constructed an empty kitchen. Most of these folders are empty except this knifeRB file, which contains something apparently useful, but everybody else is just an empty file called .gitkeep. And this .gitkeep is an empty file with nothing in it to make sure that an empty folder is preserved in a git check-in. Empty folder. If you don't have the gitkeep files here and here and here, and you try to do a git commit, the folders will disappear because they're empty. And you want to preserve these folders because that's the structure expected by Chef. Even though they are currently empty, we will fill them up. Therefore, you have this .gitkeep empty file as a placeholder file to make sure to tell Git to keep the folder. Next, we will understand what these things are through examples. I'll just give you a quick cursory idea about what these things are so that we can go and play with examples as we proceed forward. So there's a folder called .chef. It is a hidden folder. Hidden meaning it's not visible directly to naked eye on a Finder window or Explorer window or things like that, but on the terminal with a -A option, you can see it. In that folder, there is a file called knife.rb. This file is a place where you store your credentials with your access keys and secret keys and tokens and all other critical things where money is involved. And therefore, that is the area which is of abundant caution you should take to not publish outside. Do not publish this, not publish outside. That's the area of caution. Most people that are in the bootcamp accidentally write their credentials in this knife.rb file, do a git commit and push it to GitHub and make it publicly visible. That is how you make mistakes. That's how in the past people in our bootcamp have made that mistake. And this is the exact point I want you to remember, to not expose your knife.rb to public, because it will contain credentials. Right now it doesn't. It will. You will add right there. It is expected that you have your credentials in this critical file. This is how people have made mistakes in the past. There are, of course, new ways of making mistakes, but this is one of them. So don't do that. Next one, we have a folder called cookbooks. Cookbooks are basically ready-made chef recipes put together by other people or maybe by you that defines what is the result that you expect and how to obtain that result. So it's basically the instruction that you provide or somebody else provides, the instructions. There is another folder here called site-cookbook. That folder is basically also very, very similar in nature, except this is specifically you create the cookbook, you put it right here. And other people create cookbooks, you put it right there. So that whatever cookbooks you obtain from, say, this location or supermarket, for example, or there are other locations on GitHub you can get cookbooks from. Those cookbooks are coming from other people. You put them in a cookbooks folder, separate from a folder that you will have your own cookbooks. They belong in a separate location. And I'll tell you why you do that separately. There's a logic behind it. So let's keep moving forward. In our folder, we have another thing called data_bags. What does that do? So data bag in Chef basically means a place to store data, not database, data bag. So what does that do for us? Data bag is typically used to store users and passwords, credentials for runtime usage. So for example, we are talking about this outcome of the project that we are going to run. Today's exercise is going to be a database server, which will have a root user and a password that we choose. So we are going to choose our password, which means we need to write that in some kind of a credential store. We can use a data bag, data_bag. It's only singular, just one bag. Lots of bags like this will go in the folder called data_bags. In that folder, there will be lots of bags, bag 1, bag 2. And in that folder will be item 1, item 2, like that. So you have a data bag like this, or another bag like this. This is singular bag. And in that bag, you will have data bag item, like that. That's the folder structure you are expected to see in somewhere here. Currently, we have nothing. Now, the idea in this concept of data bags is to store credentials, for example, or SSH keys, or usernames, or other detail related to your application for use in runtime. That's where you use it typically to store. There are other methods of storing passwords for simpler usage. You don't have to go to the data bag example for that simple reason. And I think the first example we are going to use does not actually use data bags, but a simpler method of approaching the same thing. Next, we have a folder called environments. What does that do for us? Environments folder. This basically means a way to think about and separate in your large cloud that you might have, some cloud. You might want to create a bunch of machines here for development usage, one other for testing, another for staging, and some more machines here for production. These production machines are separate. You need to keep them separate and isolated. For environments are basically a way to classify your boxes different from other boxes like this. These are boxes that are in the staging area. So I have this box, let's say this box is a test box. So I should put that box in the testing environment. And that's how you tell Chef, hey, this is a test box. And this other box is in production environment. So I need to make sure that Chef knows that this is a production machine. So don't mess around with it. Don't run random cookbooks on that production box, but only approved production cookbooks need to go and run here. And don't run the test cookbooks here on the production. No, don't do that. That's how you classify, segregate environments. You tell Chef that that thing is my test environment. This thing is my staging environment. And that thing is my development environment. So, you have a way to classify. That's the idea behind that folder structure. It's called environments. That's what you're looking at here. Now, in the example, the next one is nodes. What do nodes do for us? Well, nodes are basically these machines, like this one, or maybe here, or each and every machine that is under command and control of Chef will have a node associated. So basically, think of it as the box, the node, the machine. Another way of saying the same thing. Basically, you have these nodes will run Chef. These nodes are basically your boxes in the cloud or your garage, doesn't matter. Next one is a role. Role directory, role folder contains another interesting characteristic. The role folder. What does it do? It basically puts DNA together. What is the DNA? As I mentioned early on, was that you inject the DNA of something into a brand new, empty, just enough operating system. And so you inject the DNA of, say, MySQL server into it. And so it becomes a MySQL server. That's the DNA injection I'm talking about. So you assign a role to a bunch of boxes. They will all become what that DNA specifies. So that's how you collectively put together roles. You can have roles like web servers. This form of machines I have are all my front-end facing web servers. So let's collectively call them web role. Apply the web role to these boxes. In here, I have more machines that I want to run and collectively call them as my application servers. So these boxes will take on the role of application server. It will all become the servers that serve my application. That's how you classify and put assignment of a function or a purpose in life on a bunch of boxes, and you call that a role. Like, what would you want to be when you grow up? I want to be a MySQL server. Great, go ahead. And so that's the idea behind a role. Then I already mentioned site cookbooks, which is a book or more books that you will create. And you want to keep that separate from the main cookbook folder because of two reasons. One, to make clarity about, hey, this is mine. I need to modify. I am responsible for these. And another one is when you give your cookbooks to another team member, you don't have to give the cookbooks in that folder because they can also get it from the internet. They can also get from the supermarket. So when you share a folder, you don't have to share that cookbooks folder. You just share them what you created and tell them a list of things that you used so that they don't have to download from you. you can just pass along a very small repository and skip passing along entire collection of cookbooks that you may be using, which can be big. And so that's the reason why we have this idea that you keep cookbooks separate from your cookbooks. I call them site cookbooks for your site. Keep them separate. And so now comes the next idea, which is the last item here in the list on that page here, which is an idea called Burks file. So this Burks file is very, very similar to where is that? Here, and here. See this gem file? Very, very similar is going to be the Burks file. Now, what is Burks and what does it do for us? Let's go find out. Burks shelf. Let's go do a Google search on Burks shelf. So that's what comes up. And you see the very first link is the right link. Its name is Burks shelf. But actually, the original intended meaning of this was bookshelf. They wanted to create a bookshelf to put books, to put cookbooks, and to manage cookbooks. You have a bookshelf, so you can manage your cookbooks. But then if you use the name bookshelf, it doesn't become a good Google search. That's why they went, Armaguard, what is that? Whatever that thing is, yeah, this thing. And they made this meme out of the bookshelf and created bookshelf. So it becomes easy to search on Google. So that's a slight deviation on the word bookshelf to create bookshelf, like Armaguard for oh my God. And here's bookshelf. What does it do? Pretty similar to what Gemfile does. There is a Burks file, and it's already there, by the way, created for us right there. And this file is what I need to fill up. Fill it up with the things I need, or rather, the books I need, or to be more specific, the cookbooks I need. So I need to fill it up. Hey, get me this cookbook, that cookbook. I need to just specify. That is the purpose of Burks file. And then you can say, Burkshelf, go get me the books, please. And so Burkshelf will go to that supermarket and grab the books and put that in the right location for you. And you don't have to do it. Like you don't have to download from supermarket like we did the last time. Don't have to do it. The tool will do it for you. So back here, let's see. We have to also examine the contents of gitignore file. So do we have a gitignore file in there? Yes, right there. And you see what we're doing? We're ignoring the cookbooks folder. Do you know why? We are going to make sure that Git repository does not contain the contents of the cookbooks folder at all. This will be hidden from our Git repository because I don't want to give this folder over and over to my friends, my colleagues, my coworkers, because they already can get it from the list that I will write here. And so that's how they will also do the same thing. I don't have to give my downloads to them. They can also download. They might have already downloaded. So why repeat? That's why will ignore the cookbooks folder. And that's that line simplify right now. And I will leave this. Actually, I'll completely wipe out my Burks file like totally, and then fill it up with new content that I want. So in that .chef folder, we already discussed the knife RB file. We'll also update this quite a bit as we go along. In fact, it is written down here how I would like it to be updated for our project. So here is how I would like to make sure that it looks like. You can see that.
Question? Hi,
yeah.
Would you want to add that to the gitignore so that doesn't get uploaded?
The knife RB?
Yeah.
Yeah, we will do it. Yeah, exactly. We'll do that. I'll guide you through exactly, but I don't want to rush into it. So yes, we'll do that. You're precisely correct. And in what Travis is saying is that you want to put this cookbook, so just like cookbooks folder, you want to put a .chef/knife.rb entry in there so that you don't accidentally push your secret stored in the knifeRB file out to the world. That's what Travis is saying, and that is exactly correct. And so that's how you would do it. And I'm saving it, closing it. There's a step written down like that. So I think somewhere subsequently you will find it coming up. Next, what I want to do is fill up my Bugs file with, sorry, this is the knifeRB. So I need to go back to knifeRB and modify this a little bit to suit my design. So in my design, I have the knifeRB, sorry, looks like this. So I'll copy that content, put it in my knifeRB, and paste. And you see I changed a little bit. What changed? This cookbook folder was before the site cookbook folder. I put it on the later second element here. It was right here before. And I am giving priority to my creations. My creations are going to be sitting in the site cookbook folder. I will create my own cookbooks. I want to give them priority over if same name book by the community provided. Somebody has provided a cookbook by the same name. Ignore that. Use mine first. So I'm giving that priority by flipping the order of the way it is written. Most of the other things are pretty similar. There is a node path, there is a role path, environment path, data back path, and Bugshelf path, which is where Bugshelf will eventually provide cookbooks to us in that folder when we run Bugshelf. Now I will save this changes that I just have made to the knifeRB, close it out. My Bugs file is still empty. It needs to be filled up. So I need to fill it up with very simple 2 lines like this. And our beginning that we are flowing with right now, the goal that we have for this exercise is to just practice a little bit before we jump into the database setup exercise, which is the ultimate end of the result, expected outcome that we have. But before jumping into database, I will begin simply by running Nginx on some machine somewhere, just to get a flavor of what this tool is going to do to a remote machine that we will start just enough operating system and play with the Nginx cookbook first before jumping on with further complications. So I just defined my Bugs file with one requirement. That is, I want to get the Nginx cookbook version 2.7.6. Just don't confuse yourself with the Nginx version. Nginx version can be different from the Nginx cookbook version. So here is the Nginx version available. Latest is 1.13.5. That's the mainline version released on September 5th. Now that is the version of the software. What you're looking at here is not the version of the software, but version of the cookbook. That's the point of confusion that I just clarified. You might think that it's the version of Nginx, but no, it is not. It is a version of Nginx cookbook available in the supermarket where you can go and search. And the book version is, it's now 7.0.0 available. But there are lots of versions. So we can just go into Nginx and see what latest versions we have available and what are the change logs, what are the older versions of that same cookbook. Apparently they changed quite rapidly from the last time. And I've been using a very old version, it seems, but it's just an exercise. I'm using this version apparently from 2015. I can update it, but I don't want to. There is no need to update. So it's just an exercise. You can update the version to whatever you want, like version 7, book version 7, just like that. In fact, if you go to the supermarket, like here, you will see that they will tell you exactly what to write in the Bugs file. Right there, I have highlighted it. They'll tell you what to write to get the latest book. This is the entry you want to put in the librarian or Bugs file. Sorry, this is the entry you want to put in the Bugs file. That's what they just told you right there for Nginx cookbook. We can grab this entry and put it right here like this, which is totally fine, but you don't have to. You can. So it is the version that what do you write in Bugs file is written, provided by the supermarket itself provides you what to write there. Next, what I want to do is ask Berkshire to please get me this book from the supermarket. So I'll say, okay, I'm going to save you Bucks file. I'll save you, close it out, go back to the terminal. And here, I want to say, hey, can you please get me the book? I want Nginx Cookbook version 276. So I will say bundle exec as the prefix, as you already know. And then I'll say Burks install. Hey, Burks, you please look at the Burks file and do whatever it says. Basically, what I have said in that file is to get me the book. Which book? I would like to get this book. So will you please? And that's exactly what Burks shell will do. So when I say Burks install, it is going to go to supermarket, grab the exact thing and put it in the right spot. And while it is doing that, it will also grab a bunch of other dependent things. Like here, there are a bunch of other books came along. All I wanted was this. It brought me a bunch of other things. And I say that, okay, then I expect these books to show up here in the cookbook folder, but not really. There's nothing in there yet. So where did it go? And what is Berkshire doing? So that's something I want you to understand. It doesn't put it right there directly right away. You expect, but it's not going to be showing it like that. So where does it go? It actually goes into the home location in a .Berkshire location. In there, you will find that there are these cookbooks. That's a central location. That's a design change that Berkshire has done to centrally locate all the downloaded cookbooks in a common location across the machine. So you might have like 500 projects that you're working on, or maybe 5. It doesn't have to repeat these downloads over and over and over again in your 5 different folders. But instead, it will keep that appropriate version of the appropriate book that you wanted in a separate folder called this Berkshire, .Berkshire. This hidden folder contains your downloaded cookbooks. And Berkshire tool will automatically bring the appropriate version of the book that you need at the runtime when you begin using it. At that time, these books will magically appear in the cookbook folder. When you execute them and you need them, they'll show up. Right now, it is hiding in that location. I'm going to go out from here, go to my cloud folder, and here I will find that I don't have any cookbooks, which is totally fine. Don't panic. The books are there, not in this location yet. Having said, this following step is not required. It's more of an illustration. So you can follow it along, but I'm going to skip. There are some things that I have described as how do you get vendor cookbooks and all that good stuff. You can play with it, and you will notice that you can also specify where do you want these books to be placed. So some customizations I have called it out. Don't have to follow those steps right now for a linear step sequence. So it's an optional step. Next one, what I want to do is define a node. This node is the machine out there in the cloud. Like I want to assign this task of make my remote execution happen on that remote node. So basically, what I'm going to do is change the pen color, make it full screen, please. There we go. And in my location, I have this laptop with that folder that I'm playing with, and this is my workstation. What I want to do now is get in some cloud, I want to get machine and do a remote execution of Chef right there. So that machine is what is going to be defined in my node folder or other nodes folder. I will have a node in there. This node is a reference to this machine. And that is what I need to have first in some cloud C, machine M. I need to prepare the machine and make it ready and create an entry here in the nodes folder so that my Chef tool will know what to do with that node, because I'm going to use Chef on that node. So I need to tell, hey, Chef, go and do your stuff on the node. So it look at the node file and go do it. And that is what I plan. So for that, I need to have a node. How do you get a node? You go to some cloud. Let's say, I think most of you have an account on DigitalOcean. So let's go to DigitalOcean. It's the simplest way to get a node or get a machine. So you can get any cloud, doesn't matter. So here, I'm logging in and putting in a token. Come on, yeah. So now I logged in. Now here I need to get a machine, get a box, just like that, click. And I am not wasting too much money, so I'll just go to the cheapest box, $5 per month. And Ubuntu is good enough OS, $5 per month, and choose the nearest region that I have, which is San Francisco. By the way you choose a box location, the data center location is not nearest to you, but nearest to your customer. That's how you should choose. Not just that, in our example, it's okay to choose the one nearest to you, but in production, you put the boxes close to your customer. So if my customers are in Indonesia, I will probably choose Singapore. Just saying, not San Francisco. Having said, currently I'm choosing San Francisco because that's what I like to be close to me. And here I'm going to select a key pair, which I already have there. And then give it a name, like this machine needs to get a name. So that name is optional, by the way. So what I'm going to do is create a machine called Web1. That's the name I want to give. So here I will say you become that node. And that name is not a DNS name. I want to clarify that. I just gave it a name called web1.cloudgenie.us. It is not a DNS name. So don't confuse yourself with these kind of names that people tend to give with a DNS name. What does that mean? It's a host name for the machine. It will show up something like, like that. See, my machine name is pro.local. It's a MacBook Pro, so Pro. That's what host name is. That's what we are assigning to the box that I'm just going to create called web1.cloudgenie.us. That's my name I chose, but it is not a DNS name. Just remember that. So how do I make it into a DNS name? I go to my DNS register, DNS entry. In my zone, I will create a name like that and give it an A record, an IP address mapped to this box. Now I suddenly have a DNS name. Without that DNS entry, it doesn't become a DNS name. So here I can first create that box. So creating a machine, plain vanilla. And I made a mistake. I should have created a key pair. I chose my personal key pair and that I cannot demonstrate. So I'm ignoring this. I'll create another droplet. And before I create a droplet, I need to create a key in the right location. So here we go, settings. And in there, security settings, I need to provide my public key to these guys. So add a key pair. And here I need to paste my key pair. Before that, I created a machine by mistake. Bad idea. I'm going to delete that and grab my key pair like this. So grab this public key all the way from here to this point. That portion is the public key. This rest of this is a comment, not strictly a part of the key. You can grab the comment also, but certain times I will tell you explicitly to not copy this portion just up to this point. And there are certain things that you need to grab only that portion and exclude the comment. So with that, I'm going to copy my public key, go back to here and say paste and give it a name. The name is ID_RSA and I add the key. This is how the critical step that I missed out on the previous creation. So I'm going to destroy this machine and create one more. So destroyed, and then I will create another droplet. This is basically going to be my node. And I'm going to say choose Ubuntu, choose $5 cheapo machine. You have $10 of credit available for free with this cloud. So you can totally use that, no problem. It's not going to cost you money as such. Only the coupon will spend away. $10 that I think you already have. So San Francisco, and here I'm going to select my ID_RSA key pair and give it a name, web1. And then create that droplet. Now this is the droplet I want to make sure that I give it to my DNS provider, which is in my example, Cloudflare. So I need to log in there and create a DNS entry. Come on, log in. And here is my Cloudflare. I go to my Cloud Genius site, DNS section, and look for Web 1. Do I already have from a previous example exercise? No, I don't have any records. So I need to create a record called Web 1 and give it the IP address. And I am doing just that. From DigitalOcean, I'll grab my IP address like this, copy, go to my Cloudflare and paste this address right here and say, add a record. Now I have a record pointing to the correct IP address, so I can close out on this window and even close on DigitalOcean. I don't need them anymore right now. I just needed a machine, I got it, and I gave them my public key. But now what do I do with that thing that I just did? I need to use it, right, somehow. So I need to basically go operate in this folder called nodes. In that folder, I have nothing. As you can see here, nothing. So I need to create something in there. What do I create? I need to create a file in that location. That should look like, I think I should go just read. So back here, it should have a file in that location, which should contain this JSON document. And make sure to create that file in the nodes folder. Don't create it outside. In the node folder, you create a file like this by that name so that it knows the node you have in mind. So I'm going to create a new file in the nodes folder, like here. In the nodes folder, I create a file called web1.cloudgenie.us, the DNS name, .json, JavaScript object notation, JSON. And in that file, this is a new file I'm just going to create for the node reference. So it knows where to go and do stuff. So that is what I just created, and it is currently empty. I need to fill it up. What do I fill? I need to fill it with a DNA injection, right? The DNA injection is what this thing is. So I'm copying that DNA injection. I'm saying, here is your thing to do when you grow up, dear Web 1. I would like you to grow up and do what? Do nothing. That's what it means. Currently it says nothing. So I want you to grow up and do nothing. This blue thing is nothing. Empty list. That's the empty list I assigned a purpose to you, dear new node called web1.cloudgenie.us. I want you to grow up and do nothing. So save, close. For right now, nothing. We'll add something to that location pretty quickly. But for right now, empty. It'll do nothing. If you run Chef, it'll connect. Prepare, meaning install Chef. But then when you attempt to run Chef with the cook command, cook command, it will do nothing. It will say, yeah, I did nothing and I came out. It came back. So that's what you will see happening when you run an empty run list like this. Next, what I want to do is put something for it to do. Right? So here I have this action for you. So I will take that action and modify our run list pretty much like this. I'll take this action, and in my web1.cloudgenie.us, I have this structure, which I will fill it up with. This is the DNA injection I want you to apply. And what does it do? It has only one injection specified in line number 3, one idea. What is that one idea? Is to run the default recipe in the Nginx cookbook. That's this idea. You can further go and say like this, : default. This is the explicit way of saying that you need to run the default recipe in the Nginx cookbook as your purpose in life. Dear web1.cloudgenie.us, I would like you to grow up and become an Nginx web server. So I save it and I close it. Having said, what it will do is it'll basically go and say, if you want to run another recipe, you will write like this, : another. So then it will pick up another recipe from the Nginx cookbook and run that another recipe instead of the default one. If you don't specify anything like this, colon default, it will run another recipe that you specify. If you don't go anything, it just assumes default. The default recipe will get executed when you execute chef. Now that you can test your kitchen, we need a machine to test, so we have the machine and all that. So we should go to the next step. We have defined a node, and we have a $10 referral apparently, so you can get that and create a node, and I think we did just that already. So I'll proceed further. And then I need to create a command to execute so that I can run, prepare, and cook. So let's go understand what these things will do for us. There are a bunch of things. I'll copy both of them and put that in an editor so I can visualize it clearly and talk about it. So here, the first step is the simple way of dealing with it, which is not written. The simple way of dealing with this is to say bundle exec and say knife solo prepare and then root at web1 dot. This is the simplest way to deal with the problem, like line number 3 says. However, if you have this other choice, it sounds complicated, but it is not. I'll tell you why. The other methods of dealing with the same problem are slightly more elaborate. They apply, like line number 7 through 10 applies to a case where you don't have a zone file, or when you have something in your local data center that doesn't even have a public IP address. In those situations, line number 7 through 10 will apply. And that will be something like here. The internal IP of your box in your company, something like that. So it may not get a public DNS name. So you still want to assign it a name and use it and operate it internally in your company. You can do it like that. So internally, you might have something like 10.0.11.13. So that's okay. You can assign those names. They will not be resolvable from a public internet, which is fine. So if that's the case, that's the scenario, and you still want to use internal machines and still want to have a DNS resolvable name to assign, you can go like this. In the simplest way of dealing with it, if you have DNS routable machine and you have a DNS entry, you go line number 3. If you still feel lazy about putting a DNS record, you can go line number 12. Line number 12 and 3 are very, very similar. In that, what we are doing is, let's go compare what the differences are. The differences are that I am going lazy and not being religious about putting the IP address in my zone file. That's what it boils down to. So that's generally a bad idea. If you can do something, you should do it properly, like Cloudflare entry that we have. So you should do that. And that's why I did it. But you don't have to. That's what I'm saying. You can cheap out and say, you know what, I don't worry about my DNS part. So I just say, that's okay. It works. You just have to call out this name -n option, and then it will automatically pick up the correct node file from this location. There is another way of doing the same thing, by the way, which I haven't written down, but I just thought of it. That would be a fourth way, and that would be something like this. That you really want to go really, really lazy. So what you do is you get rid of this part as well, and instead create a file called nodes/ and nodes/ and then, and this is esoteric, so you don't have to do it, but you can. You have to create a file like this in your nodes folder, and then go like line number 6. That is also okay. So variety of ways of dealing with machines, defining them, accessing them. You can put a file like line number 9 in your node folder, or you can do it like this, like we have done in our example. What we have done is said web1.cloudgenie.us .json is the name of the file that I have in our example number 3. And so that works. If you don't have that, then you have a scenario where you can use this method. Line number 10, you create a file like that with the IP address .json. Then you can use line number 9 as a command also. That also works. So the variety of ways of dealing with this scenario. We will go with the first one, the simplest one, because I have set up my DNS entry and I have a file called line number 4 in the right spot. I should be able to just run it simply the first way. So copying that, go to my workstation and go to the terminal. And here I want to say, using my knife tool, I want to prepare the machine out there in the cloud. Preparing means what? Preparing means install Chef. This box doesn't have Chef. You know this, just enough machine, right? Just enough OS. So let's go see if we can even connect to it. So SSH, can I even connect to you? I think we can, pretty sure. So it says, yeah, I can connect, and I got connected. Nice. So now I exit. I know I can connect. So I do not want to connect to the machine and mess around with it. Because anytime a person touches a machine like that, you are creating what I call entropy. Entropy is a law of thermodynamics, third law, which you probably know if you know thermodynamics, is that people create chaos, and chaos is bad for production. So you don't want to touch machines in the production. Absolutely not. So although I attempted to connect like this, I shouldn't have. But it's okay. I just wanted to make sure that you understand this. That's what I did. Having said, I will now ask my knife command to go prepare that box. And what do you think prepare does? It installs Chef. It does not run Chef. So here we go. Bundle, execute, what? Knife, solo, and then prepare. Prepare what? Root at that box called web1. Please prepare that thing for me. And so it is going to prepare that thing for me, just like that. Off it goes. It is going to bootstrap Chef, that remote location, SSH connect, install Chef in that box, and report back saying, I did it. And great, thank you. So that's what's going on. You can see that this is actually going to grab Chef. It downloads Chef version 12.10.24. Not the random version of Chef that you feel like, exactly what you wanted in your gem file. You know you have called it out, the versions of Chef you need, and that is exactly what is getting installed right there. And I think it reported success. So it should have done that thing by now and said, yeah, thank you for installing Chef. It said that. So it installed Chef, nice. It installed Chef on the remote machine, not here, remote. So this box now is under, it can run Chef, by the way. It has been prepared to run Chef because we said, knife solo prepare. And so it did. And what I will like to do next is to say cook. And what does cook do? It runs Chef. And so when it runs Chef, let's go see what is going to happen. So here we go, full screen, and put this on one half and the Atom editor on the other half. That's much better. So I'm going to cook my box. Off it goes. And so it says, okay, I'm going to check the version number of Chef there, and it says, I have it. Now suddenly you will find that these cookbooks got uploaded, and these books show up now in my cookbook folder automatically. That is beautiful, thanks to Botchef. And the books were sent over there, and along with that, all the dependencies are also sent over there. And the action expected was in the node definition. What's the node definition? It has my DNA injection, and the DNA says, line number 3, please make the box an Nginx server by running the default recipe in the Nginx cookbook. So we now have the service ready, started, and all that good stuff has happened, which is nice, by the way. But one thing that you will have to believe me to begin with is that this machine did not have Nginx to begin with. And I will assume that you agree with me that I should have checked to begin with that the box doesn't have Nginx server, and now it does. It shows you a 404 page. I'm so happy to see a 404 page in my life, is because it is actually giving me a 404 generated by Nginx. Because I installed Nginx. So it is showing me that it is running Nginx, which is what I expected. That's my purpose in life as defined in this default recipe. That's what you saw. And next, what I want to do is continue the evolution of our understanding of Chef usage in the context of a cloud by proceeding forward. So I'll close this window and go back to what we were doing here. And you will notice is that we ran the cook command. As you can see here, there are various variations to running that cook command. And then I also proceeded and installed, ran chef by cooking. So prepare and cook, 2 steps. So I think I did both. So here is the cook solo cook command, and you will see the output you saw, and happy about seeing a 404 page. And then the next step is idempotence. You probably understand this already, but I'm just going to show you that idempotence concept, which is to go to that machine directly and create some mess like this. So I'm going to go to that machine, like directly there, and in that machine, what I want to be able to do is uninstall Nginx. Right now, it has Nginx running. Yes, it is running. So I'm going to say, you know what? Just get rid of your Nginx. This is creating trouble, creating noise, creating chaos. And I'm doing that deliberately so that I can ask Chef to fix it for me, just to illustrate a point. So here we go, sudo apt get remove Nginx, and off it goes. So it will be removed. And then the dependencies, auto remove. So everything is gone now from Nginx perspective, and nothing works on that site again anymore. So you can see that unable to connect. That's expected. Now we will run our cook command one more time by exiting this box, and then run the cook command one more time. Cook the machine again. It'll do you exactly what you expect. Is send the cookbooks over there, and then run the DNA DNA injection that we have specified, which is right there. It will do exactly that on that particular box. It knows, it keeps track of all these nodes. We have only one right now. It knows every node and its purpose in life, so it will implement that purpose in life and come back. And so now we have Nginx started, which means we should see the 404 page again. And we saw it. That's the idea behind a idempotency that you already understand. So you saw that. We will proceed further, forward. What I want to do is now define the idea of a role. Like I said before, roles are a collection of DNA, DNA injections put together. So if I have, let's say, a server farm with hundreds of servers that are going to be my web servers, Nginx servers, I can create a role for them. And for that, I need to create a file called the web JSON. By the way, these files can be constructed in 2 different ways. So there's a question here in Slack chat. Let's go see that question first. The question is break. Okay. Yes, break. Sweet. So let's go take a short break, and we'll resume with the role discussion. And that's what we will do after the break. So here is the timer. Thank you for reminding for a break, and which I completely forget. So, yeah, the break started. Okay, guys, let's see who's back. Oh my God, you guys are hilarious. So, Christopher Snook comments in private one-on-one that at least act like you're taking a break. Oh man, he just saw me sitting here doing, other stuff, but not really taking a break. As in, I don't have to walk away. But that was funny. So, okay, let's proceed. Okay, let me project my screen again. And we'll now talk about this other idea of roles. So back to my whiteboard. You saw me define a node file and put that file in the nodes folder. And that file name can be whatever you have, whether it's a DNS name or an IP address .json. That's how the structure for a node file looks like. And in that node file, you can then put in your run list. The run list is basically what you want it to become when it grows up. And so the other way to put this run list is what is called a role definition. So a role definition goes in a roles file, roles folder, and then you have to have a role name .json. And that role definition will go in that file. And you can then apply this role to a collection of machines, not just one machine, one IP address, like the nodes definition will do. In roles definition, you can apply it to a collection. Lots of machines get the same role applied. That's the scenario. So we have to create this role name.json. It's a separate file, belongs in the roles folder. And that's what this step is. So we have to create a file called web.json, put that in the roles folder. And in that file called web.json, we'll create that first back here. We'll say in our roles folder here, right click and create a new file and give it a name. The name that I would like to choose is going to be web.json. And that's the name for that file. It gets created as an empty file to begin with. But now in that file, what I want to do is paste some of the content that will define that role. That content is provided as a template right here. So we'll grab it, bring it over here into our web.json, paste it, save it, and then look at it, see what we got. So here you will see that there is another way of defining that DNA fingerprint or DNA injection mentioned right here in line number 12. This is the run list that we called out in a node file before. And now we are going to specify some additional attributes right here. Additional attributes being called out. For the role being web role, this description is a human readable description. You can put whatever you can find intelligible. It doesn't matter. Here is the type of the file itself. The chef type is a role file. JSON class is a chef : role, meaning it's the JSON class that you're attributing to. And in here, the key things that you have to remember are this line, which is calling out the default recipe in the Nginx cookbook, and this line, which is defining two attributes. They are the listen port attributes for specifically opening up two different ports on which Nginx should listen. Nginx can by default listens on port number 80. And so since we are now thinking about HTTPS requires port number 443 to be open. So we want Nginx to listen to that port as well. So that's what we have defined here in that segment of line number 8, is to ask Nginx setup to listen for additional port number 443 that we are going to specify in form of a attribute definition override. This attribute is already here in cookbook Nginx
attribute default and go look for listen port, you will find it right there. 80. This is in the cookbook itself. We want to expand it and say you should listen for not only this port, but also this port. And that attribute override is what we are providing in this role definition called web.json, because I want these servers to be HTTPS capable. I'm planning for it, and I'm expanding my collection of ports that I want Nginx to respond to include this as well. So this segment you're looking at here is the extension or override on top of what are the default attributes in the cookbook. They are, there is only one, 80, by the way. So I'm expanding it to include another port. And then I'm going to run the same recipe before, except this will get executed from a role definition. So this role definition, somehow we have to have our node understand. Our node needs to know, I'm going to save this file, by the way. So saving it, closing it. Our node that we have here needs to know that it is not going to run the recipe directly, but instead it's going to become a web role. It has to take on the web role. That's how I read it. So I removed the reference directly to a recipe, the default recipe in Nginx cookbook, but instead I said, you dear web1.cloudgenie.us.json, when you grow up, I want you to become a web server. That's the role, that's the purpose in life for you. So what does that mean? You go and follow along here. And that means you have to basically run the default recipe in the Nginx cookbook and at the same time open up 2 additional ports. That's what it means. That's what this machine will do when you run chef again, or when you cook it again. And so we have modified that. So we have this before, we removed it and make it role web now. That change we made because we can now use the role reference. That's how you use roles, by the way. So in our example, we should now be able to use the role reference directly by going to the command line and say, here, you cook again, and it will go cook. But this time, it will go look at our role definition, because that is what we have called out. So it will go and cook again, and this time it will push or send the role definition as well, because that's a new thing. It will accomplish the same idea, the same output, the same result, but through a role reference. As you can see, it will show you. I hope we can catch it. Not in the command line so easily, but there is. It succeeded doing the same thing actually, and it did nothing much because it was already set up. So we should be able to see that we don't see anything changing here because it is still the same. And we are able to accomplish the same idea by referencing a role like this, role reference. And that role was here. I think you get that point clear. That's how you use roles, by the way. You can make it more complex. And one more thing to remember is that these JSON files are JavaScript object notations. This is just one way to do things. In another subsequent exercise, we will use the Ruby way of doing things, the .rb file. The same thing in Ruby. You write in Ruby, it is also accepted. Totally fine whether you want to use JSON references like this or the Ruby references, which will come down the road in another example. Having discussed that piece, let's go move on to the next step, which is, let's see what is that next step. I think we are basically walking through the folder structure to understand what those components are. And we discussed roles. Next thing I think is you can assign multiple roles to a node. Meaning if you have like multiple purpose to a particular machine, for example, you want to give a role called database as well as the role called web server, you can assign a run list that includes a role reference, comma, another role reference. You can do it that way. You can, if you do it this way, it will become a web server and also a database server. That if that's the desire, if that's what you want, you will write it like this: web server you grow up to become a web server, and also the same box will become a database server. That's how you define a multiple role assigned to a machine. By the way, this is not a part of the exercise. This is just an illustration of how to assign multiple roles. So that particular thing is not supposed to be done. I'm calling it out clearly. Don't do this step when you're doing the exercise. It is more of an understanding of how you can. So this is not the exercise. Moving on. Next here, you can even mix and match recipes and roles together. For example, here, one role called web and a default recipe in the PostgreSQL cookbook, mixing and matching recipe references and role references like that. You can, it is legal and allowed, and it works. But this is not an exercise step. So just remember that. When you do it, you can skip. Next one is, this is again not a part of the exercise, but something to understand, that you can also override certain attributes that people provide. People meaning people who write cookbooks. There is a question.
Hey, Nilesh.
Yes.
So if you remove a role from the definition for a node, will Chef, when you cook again, automatically remove the stuff that was installed for that?
Yes. It may not uninstall. It may not. It may not uninstall. I think we have to test and validate that piece. I think it doesn't uninstall. You would assume that it does. And that part is basically this discussion, which I have, is I would not take risks in. So what Brian is describing is this point. Let's say you have, this box, and you give it a role called X, and then you give it also another role called Y, and you apply that role, so it takes on and becomes X and Y. Later on, you come down and say, you know what, I am going to remove this role. And then you have the machine already running X and have the machine running already as Y. And what Brian is suggesting is that what happens that if you remove the Y function from your role definition and run Chef again, the output will be X and Y. It doesn't actually delete or uninstall. It has no way to figure it out. It has no way to understand and be aware of the fact that, hey, you just removed Y. So it will keep Y as it was. It will update X as you wanted to in this example and leave it alone, leave Y alone. If you want to have a system which basically replicates and mirrors what you have in mind, like here, you want the scenario of Y getting removed, that is not the Chef product. It's Terraform. Terraform will do these things, I think, for you. And we'll play these things as we do Terraform exercise. Terraform does kind of sort of what you just told me, the question you asked. And I'll demonstrate this live. I think Chef will just ignore Y pieces, the Y piece, and move on with just ensuring that X is correctly installed. That's my understanding of the current default behavior of version 12 of Chef. I don't know. I haven't played with 13 yet. Things change quite frequently. So my understanding is this version 12 will ignore Y, keep it here happy as is, not touch it. That's the answer to Brian's question. Next one, back in our exercise. This is an illustration of how do you handle attribute overrides. So for example, if you go to GitHub and find out a particular cookbook, there will be lots of them. And in here, let's say what the example I am giving you is listen address, Apache listen address. And so you can basically go to the cookbook itself. How do you go to this spot? You have to go and first of all, go to supermarket. And in supermarket, you search for Apache cookbook. For example, I'm dealing with Apache 2 cookbook, so I'll grab that. Then I want to read the book itself. So I go to the view the source, and I can view the source in GitHub. Now in GitHub, I will see that the whole book is these collection of files. I'll go there and look at the attribute section. That's what I was interested in, reading the default attributes. So I can override them as I need to. And here I see some examples of what I can override. And if I find something of interest to me, I can modify it. For example, something that is of interest to me would be to set the timeout value. Maybe I want to increase the timeout value in a development environment so that the timeout values are longer. So I can finish my quick testing that I may be doing for my development purpose. I can modify that timeout value if I like to. And so for the development environment, like we mentioned, you could modify the timeout values like in, there. Keep alive timeout value. I want it to be 30. So you can modify some specific value of timeout by overriding the default attributes chosen by these guys to be 300. And in my example, I have chosen the Apache keep alive timeout value to be 30. You can modify according to what you need. Whatever they have chosen, these default values are considered sane defaults. Excuse me, sane. They're supposed to be good, generally supposed to be good. Of course, in your case, it may not be sane. They can become insane. And so you don't want to be insane. And so you can override these attributes. They're generally considered good, sane defaults. They're provided to us by the community at large, working, collaborating together. And they have written these things down as, generally speaking, attributes that are considered sane for a common deployment. So if you do nothing else, the defaults will take into effect and things will happen as you expect it to happen. But if you want to change, you can. The way to change those things are through modification of attributes. These attributes are in the cookbook. They are a subfolder of a cookbook called the attribute folder. Inside every cookbook, you will have it. That's where you define attributes needed for that particular cookbook. And this is a brief discussion about what attributes do for a chef run. And that is also not a part of the exercise. There's nothing to do here, but just to understand. Next one, we'll proceed forward. And where is that? Again, next lesson. And here we are defining environments. Again, this is not a part of the exercise, but more about discussing that my development environment, I would like to have a timeout value of 120, as opposed to my other environments will keep the default, whatever that default value is. So this is an example of an override attribute that I would like to have for my development environment. And this file is another JSON document called dev.json, and it belongs in this folder right here, the environments folder. That's where it needs to go. So it needs to be there in the environment folder by the name dev.json, and should call out that all my machines in the development area of my cloud will have a different timeout value than everybody else. Everybody else will have whatever the default value is, but in case of my development environment, I would like to have the default attribute for Nginx timeout value to be 120. That is how you call it out. Again, this is not an exercise, so we'll proceed forward. Next, we are going to define data bag and data bag items. And this is again another exercise in the understanding of what these things are. And so I would like to call out this fact that Knife in its solo implementation and Chef in its solo implementation does not support data bag as provided by the Chef developers. But then there are other developers who have come in and pitched in new source code that enables support for data bag for use with Chef solo, Knife solo. That piece of software created by somebody else outside is available in this gem. It is called Knife Solo Data Bag. You can go search it. It's available in this location, and I want to use it. So the creators are these guys who created that, and you can use this gem called Knife Data Bag command with solo. So Knife Solo Data Bag, and to be able to use any gem, what do? You take that entry and put that in your gem file, right? That's the first thing you do. So here is our modified gem file. We copy that gem file, take it to our location here where we have our gem file located, and place the updated version of gem file and match and watch and understand the differences. What do we got as the difference? We have this line, the same number, this line, same number, this line, same number. This is also the same number. The only thing we are adding is this new gem. So that's what we will do. Just added line number 6 as a new gem in there. And I would like to now save my gem file. So this method of managing your dependencies and whatever you need will of course require the discipline of putting another bundle together. So I have to update my bundle. So a bundle update. So now this time it will go to Ruby gems location and find the missing item right there and installs that particular gem into my system. So now I have the ability to operate on data bags as well, even though Chef Solo doesn't have the support needed by itself. So we added extra capability. As a consequence, we get new commands available to us. We can see them like here. And so we see the new commands available to us in a command line that goes like this. We'll say bundle exec knife solo -- help, and then pipe it through grep to search for bag. And so, okay, I think it's no knife solo help, just knife help. Now, no solo there. Yeah. And so it will look for certain bundle exec knife help, will come out with a lot of output. I want to filter that output to focus on the bag related items. So this is a filter step. I'm filtering out all the output and limiting myself to the output that contains the word bag. And so here are the options. As a consequence, we have new command capabilities available in bundle exec knife solo to create a data bag, to create and edit a data bag, to list out the items in a bag, to show the bag item. Those capabilities got added. It did not exist before the addition of that new gem that we just created. Now, what does that do for us? It will help us create and manage a data bag item, and put that in the bags folder. Our bags folder is right here. It is currently empty. Now we will proceed further. And what I want to do is, first thing, create a bag where I can store my credentials, like password, for example. So I will do exactly that. What I will do is read this line first of all. It's kind of a long command. So I'm going to read and help you understand what that does. It's too many words in there. So go like this and type it and dissect it completely before we proceed into execution. The dissection of this goes like this. So bundle exec, you already know. It is the prefix that is necessary. Knife solo, I think you understand that we are using the solo version of using Chef, solo version of using the knife tool as a part of Chef. This idea is to create a data bag. I think that part is clear. Data bag create. So knife solo data bag create. And now these two items, what do they do? So we have to understand what is pass and what is MySQL. So pass is the item and MySQL is the bag. So this is item and this is the bag. That's what I want to create. I want to create a bag called MySQL and put an item called pass inside the bag called MySQL. So I want to create a bag and put it in the right location like this. That's my goal. So my pass is the name for the item. MySQL is the name for the bag that I'm creating using knife solo. And of course, I'm prefixing the whole thing with bundle exec. That's the longish command that we are going to type like this in here. And off we go. But before I go, I want to see my atom editor on one side and the command line on a portion of it. So here we go. I'm going to paste it and run it, and it will tell me, actually it will create a new bag. Basically it creates a new file and puts it in the right location in the data bags folder. And it also opens up an editor. In that editor, you are expected to provide the password so that you can save this item pass in the bag called MySQL. That is going to happen as soon as I enter this command. A new editor will pop up. It is not the Atom editor. It's a different editor called gedit. In this machine, it's a different one. And I'm going to run it. And I said enter. It pops up a new editor. This editor is the gedit editor. You can minimize it like by clicking this button here, that one. I should say unmaximize it, not minimize it. So this button, you can unmaximize like that. Like this one. That's the squarish one that you need to remember. If it goes like full screen like that, you go to the very top and that's the button you click to unmaximize it. Now you see this in this window, there is this editor open and my command is still executing. It's not finished yet. This command that I ran is executing right now. In the foreground, you have this new editor called gedit running. It is expecting me to do something. It's expecting me to give a password to store by the name pass in my bag called MySQL. And no, I think I misspoke. I think the name of the bag is pass and item name is called MySQL. So I should paraphrase that. I'm going to save this and confirm and read the output. It says created a bag item named MySQL in a bag called pass. So this pass is the bag name and then item name. That's more logical. When you create a bag and put an item in there. So this MySQL is the item. This is a bag. You can see that output in the Atom editor in the data bags folder on the left side. You can see it. I'm going to show you in the terminal as well. You can see that there is a bag and there is an item. That's the structure. You have bags, plural. Then we have one bag here and then the item inside. That bag contains nothing much, just a reference to an identifier called MySQL. We'll fill it up again. What I want to do is provide a super secret password in there. So I will go and in that location, put in a comma like this and provide a super secret password like that. So thereby I am storing my super secret password inside a data bag item called MySQL in the bag called pass. And I just saved it in the Atom editor. If I make a mistake, I can basically delete this pass folder completely like that and move it to trash. Now I have lost my bag, which is totally okay. You just have to create it again because you deleted it. So I'm going to create that bag again. The bag is getting created. The editor window opened up. In that editor, I need to actually provide a password. So I'll say my password is this. And I remember to put this comma right here. If you don't put that comma right there, it will complain with the red ink. You can see that red ink. The moment you put that comma, the red ink goes away. That's an indicator of error in your JSON. So this JSON structure expects a comma after every entry, except the last one. And so if you don't have that comma, if you just paste the ID colon super secret password, then it will complain with a red dot. So you want to make sure that you have the correct item written in the structure expected like this. And then you save that JSON and you close out on the editor called gedit editor. When you close it, it goes back and says, I created a data bag item called MySQL. And that item shows up right in that location here. So that is expected. This was a clumsy way of creating a simple file. However, this is the only way you can when you're dealing with a Chef server. The Chef server has to create that JSON file in a remote location away from you. Typically, Chef server is away from you. It is not your laptop. In your laptop, you can, of course, modify a file using Atom Editor or some other editor and deal with it. But that is not possible when you are dealing with a remote computer. That is available only through Chef to you. So the only way to modify a data bag item, unless you're using a web browser and sophisticated tools, the only way to do it on the command line is this kind of a method. So bundle exec, knife, solo, data bag, create, data bag, edit, data bag, delete. That the action is right here. Create a bag, delete a bag, edit a bag. You can actually edit the bag just like that. You can say, instead of creating, I want to edit my bag. So here we go. It'll open the editor again. And here I can modify my password, say 123. That's my password. I save it and close it. And now my password is modified remotely. I edited my MySQL item stored in the pass bag in the data bags folder. It appears to be a little bit clumsy, but it is a necessary thing when you're dealing with remote data bags in a Chef server setup. Having discussed this piece, let's see another interesting idea, which I think you will enjoy. And that idea is called, let's see if that's the next idea. Yes, the next idea is encrypted data bag. This is where you basically encrypt your secret, your password, before you send it out to the Chef server. And that encryption needs to be controlled by you. And so that means the encryption keys you need to retain control of. That means you have to create a method of encrypting stuff before you send it out to the Chef server or some other location to send your secret information, like this one, for example. 123 is my secret, right? My password. So I want to protect it, encrypt it, and then store it in a data bag, and then give it out to my Chef server and manage it and use it and all that, but keep it encrypted. That's what I want to be able to do, for which I require an encryption key. I will have to create one. How do I create one? I'll go like this. I'll use the OpenSSL library to generate a random number, base 64, and I will choose the length 512. So here it goes. It creates one. The random numbers, basically random generated string. I got it. What do I do with this? Not really ready to use. So I have to process it. A little bit processing. What it needs to do is, at the end of this D, for example, there is a new line character. It's the end of line indicated right there. Similarly, at the end of V, you have a new line. End of plus, new line. F, new line. T, new line. This is basically truncated at the end of these so many characters. And a new line is inserted by this command and it generates them. So what I want to do is generate another, but then I want to filter it out and trim any new line characters and any carriage returns I might have. I filter them. And so what happens as a consequence? I don't get those enter after D, enter after V. I don't get them anymore. At the end of this line segment, I see that there is a new line character. I don't want it, so I filter it using this command right here. The TR is going to be trimming it. Trimming all the /R and /N. These are carriage returns and new line characters that I'm going to chop them off and get rid of it. So here we go. It filters. And you can see that it is slightly different from the first time I ran it. I'll do it again so you can clearly see it. But here we go, full screen. and clear, and run it without, and now run it with the trimming. You see the trimming part actually trims out the new line characters and the carriage return characters, like right there. A /r is carriage return, and /n is a new line character. We don't want it in our key. We just want a consecutive 512 character long random number. And that random number is what I want to be able to use to create as my encryption key. So what I want to do is get this in a file, save it, and use it as my encryption key. I want to use this and put that in a file in a specific location. What is that location I have in mind? I want to use it this .chef location. That's where I want it to go in a file by the name this. That's the file I want it to go in. So I will do exactly that. I will say, you please create this longish thing by the same command like before and redirect the output into, let's go rearrange a little bit so you can see it happening. In the Atom window, you have .chef folder open for view, and I am going to generate another new random number and truncate, kill out all those /r/n entries, and then redirect the output like this over to a file by the name encrypted data bag secret. This is the secret I want to use to encrypt my bags as I send it out or do whatever with my bags, so that only I can see what is contained in the bag and nobody else can. So when I run it, it will create a new file in the .chef folder that you can see the file getting created. Here it goes. The file got created right there in here, encrypted data bag secret. If I go to see the file, it is basically a long string of characters. This is the key that I want to use. And only I know the key. Nobody else. I just generated it. Random characters. So now I have it. I saved in a file. Call it my encrypted data bag secret. And that is my encryption key. I would like to use it in my terminal right here before I create this. This encryption key is available to me. What I want to do is use this encryption key to generate a different bag. And for that, there is an even longer command. And that is something that is similar to this one that we saw before, except it has an additional component to it. So again, bundle exec, common. Knife solo, yes, we are using solo. We are going to do data bag create, correct. We are going to create a bag called passwords for MySQL as the item. And this time, this is an addition. I'm using a secret file reference, and I'm pointing it to the secret that I want to use as my encryption secret. This file that I just generated, I want to pass it along in line number 12, along with the command, so that this longish command, it's very long, but it will create a bag called passwords, different from the pass bag. It's a different bag, but contains basically the same information encrypted. I want to create this new bag. So copy, take it to the command line here, and I'll say data bags, you have a bag called pass and a unencrypted item called this, whatever you see, that is unencrypted. I want to now create another bag with the item that is encrypted. How do I do that? I want to go like this. And it says, okay, I open editor for you. So I see the editor right there. And here I can say my password is going to be what? My password is going to be really secret, strong, really strong password. Yeah, that's a good password. So I'm going to save it now. and I save it and I close the gedit window and the command comes out. And that's good. It says created data bag item by the name MySQL in a bag called passwords. So you can see that bag created now in here, passwords. In that bag called passwords, we have another item called MySQL JSON. The previous time we created a MySQL JSON, it was not encrypted. So we can see it and read it and understand that this is the password stored here as 123. However, the password that I just saved in that gedit editor was encrypted using the encryption secret that I passed along like this. As a consequence, the file it generated and is stored in this item called MySQL is not human readable. You can see how it is not, like this. It has the same structure, ID MySQL, password colon what? Password colon what? That's what it is. That what is a reference to what I wrote, which was super strong. And it created an encrypted version of the words super strong with AES 256 encryption right there. And this is the encrypted data, begins from this point all the way to this point. And nobody can understand what this thing is unless they have the decryption key, this key. If you have it, then you can understand what this thing is. Otherwise, you cannot really make out what this thing actually is. There is no way humanly possible with today's computing technology before you die that you can actually decode what this means unless you have the decryption key with you, which is easy now. If you have the decryption key, you can just run and say, hey, show me, like this, like knife, whatever, instead of the create step, this create step, you say, show me my password. So it will just show it to you right there, really strong. It just showed you because you said, use the encryption key to show me my password. So it showed you. Fine. I want to now edit my password. So I will say, edit my password. And it will open the editor one more time. And in the editor, it will show me the English language version here. And I am going to modify it and say, not so strong, and save and close and quit. Now the password encrypted version changed a little bit on you. You must have noticed that. I should have cautioned you to watch for it. I'll do it again. Watch for the encrypted data changing as I modify the actual, as I edit the actual password in a human editor, like not so strong. I'll make it to be very, very strong. And I'm going to save it and quit. And as it quits, you see the line number 4 changing. So I'm going to save it and quit. There it goes, changed. Something happened. This change is happening as a consequence of new generated encrypted data stored in the MySQL item, in the passwords bag, in the data bags folder. That's how you encrypt. And so when you're dealing with a remote server, remote chef server, and you still want to manage your secrets, your credentials, and you don't want to give it to anybody, you want to hide this encryption secret from other people, public at large, anybody else, even people who manage your chef server. You don't give it to them. You keep it in yourself, in your control, and you ignore it like this. So Git people will, Git repository will also not obtain that same thing. Something like this. Is that the name? encrypted data bag secret. So yeah, the name is correct. And I put an entry in the gitignore file so that my Git repository will not capture it in case I want to publish it to the world outside. This particular encryption secret will be left out. It will stay only in my machine. Gitignore this file. Okay, that data bag encryption is interesting. I think most people find it interesting because it is something that is there in front of you getting encrypted. And so if you haven't seen encryption before, maybe you run this exercise yourself. However, we will now proceed with the next step. You saw me editing, you saw me modifying, you saw me showing the encryption secret and all that. And this command that I just typed, line number 4, is really long and kind of boring. And I actually generally call it cumbersome. So there is a shortcut to reduce the trouble of having to type all these things. So what you can do is you go back to your knifeRB in here, in the knifeRB file. And in there is a line number 6 provided to you already. So you have to modify that line and say that, you know what, I have an encryption secret. Why don't you just use it? And don't make me type that thing over and over because I'm tired of typing all this thing. So I want you to use this key. And so why don't you just remember to use it every single time, for which I need to modify it like this. So you have this line number 6 that basically has a comment about encrypted data bag secret. So I need to remove that comment and put something actually useful like this. Like it was before like this, now it is like this. This line number 6 is a reference to my encryption secret. And I've stored it in that location, this secret. So I'm basically asking my knifeRB, hey knifeRB, I know I have that secret there. Why don't you just use it? So that I don't have to type it over and over again because I'm tired. So that's what this knifeRB does for us, that you don't have to type it over and over again. You can just say, cut all this out and let me edit my password in the bag called passwords. And this item I want to edit. So here it goes. Without explicitly calling out the reference to your encryption key, you can make this very, very strong. Call it a weak password, 1, 2, 3, save it and close it and quit. And it is still not human readable because this thing has encrypted. It's going to be like that. It is usable, but not human readable. Okay, proceeding forward. Now we are going to do an exercise which I think I would like you to do. And that exercise is defined right here in these lines. The desired outcome is called out. And what I think, having said, there is a cheat sheet available right after this at the very next page, which basically accomplishes this exact outcome. So the desired outcome, let's go read that. And the desired outcome is like this. The outcome is we have a node, meaning a machine, ready, accessible online via SSH. That's the machine that I think you need to create. You have to have MySQL server installed on that machine. The server needs to be running and ready with a root password that you select, something like 1, 2, 3, for example, that I like to use as a quick reference. And then after a chef run, that you can log on to the server machine and then log on to the MySQL database server on that machine, on that node, and confirm that the MySQL server is actually running with your chosen password 1, 2, 3, and connect to it. Make sure that you verify that it actually is a database server ready for access. And then how do you do this? that is provided to you. You can just see it in the next step. But before you see it, I want you to think. I want you to think about how to make things happen. And this is one of the simpler exercises of using passwords and all that. Therefore, there is a critical thing that I want you to remember. As you start a new machine, please use 1404 Ubuntu for this exercise. That's a critical step. 1404, not 16. The default choice that is provided to you in any cloud these days is 1604. I would like you to go 1404, one generation before. And I'll tell you why. What I have attempted to do in this particular exercise is to keep things as simple as possible for us to accomplish the outcome we want without unnecessarily complicating stuff. This Chef tool is a complex tool, but I don't want it to become complex. I want us to focus on understanding what things are happening to make sure that we really understand before we proceed in more complex stuff. If you actually go to the MySQL, by the way, is going to be the cookbook we need. Of course, you can guess that. Is you go to supermarket, and then since you are thinking of installing the MySQL software, you go here and grab the MySQL cookbook, which comes in this latest the version is 851. However, I am suggesting to use a slightly older version of MySQL cookbook for the primary purpose being ease of understanding, so that we can really make things happen quickly in the next 20 minutes. And so that's the version that I want us to focus on. This is version 5.563, whereas this version seems to be 851. So slightly newer are available. If you go look at changes, this version 563 is somewhere here. 563 is missing. They deleted it or what? Huh. Hope that version is still available. 561 is available. 563 is not. Interesting. So they keep modifying stuff. Let me go quickly check whether that particular book is available. View source. Go tag. Version 563 is there. Okay, it's there. So no issues. We should have we would not have any trouble. It's just that this documentation seems to be missing the references to changelog for version 563, which is fine. Not a big deal. Git still has it. So if you now think about what the outcome that we want versus how do we go about thinking of implementing and accomplishing that outcome, that is what I will talk about briefly. So here, what I want to be able to do is have a machine in some cloud. I will prefer to go to DigitalOcean to begin with right now, get a machine called what do they call these things? Droplet. Get a droplet. And in that droplet, the outcome I want is this machine to become my SQL server with a root password of 123. And then I should be able to log on to the box and see I can connect to the database and all that good stuff. That's what I expect. To make this happen, we need a cookbook, which of course is going to be the MySQL cookbook. That's no doubt I don't think anybody has any doubt about that. We need to grab this book. I'll grab this version of the book, and then I'll say, you know what, go and run it. But then there is a critical step missing. How do I provide my password? That piece. And so I'll in this example, what I have done is provided you a even simpler method of passing along a password without having to use data bag. That's what I have attempted. And in a subsequent step, we'll use encrypted data bag and all the more complex things that are expected. We'll do that, but not in this exercise. I am keeping this exercise primarily simple to make sure that we get through the concept clearly. And so we need this particular book like that, which needs to belong. It belongs in the gem file, by the way, right? You know this. So we go back to our command line in this gem file location where we have, sorry, Burks file. What did I say? Burks file. It belongs in the Burks file. This belongs here. So I can get a new cookbook for MySQL and save and get rid of it. Get rid of Nginx. I don't need it anymore. And so save. And you will see that this book reference is now added into my Burks file. As a consequence, I need to run Burks update because my Burks file changed. So I need to go here and say bundle exec Burks update. And it will go to the supermarket, grab the MySQL cookbook for version 563, the one I want, and put it right there in the right location. The right location is not this location yet. By the way, there are a bunch of books here. We don't need any of them, by the way, so we can get rid of it because we just strike out the reference to Nginx from our Burks file, so we don't need those books. In fact, you can and you should delete something like this. rm-rf cookbooks and create a cookbook folder like that. So it's empty now. And then our Burks file we just ran, it brought down that book that we wanted by doing this Burks update command from the supermarket. So we have the Burks file up to date. This cookbook available in our bookshelf. Having done this part, we will now define node number 2 called web2 or any name that you choose. This DNS name is something that you can create separately, which is a recommended practice. However, for today, to answer the question that Brian had early on, what happens if you have X and Y and in a chef run and you apply that to some box here, and then you will have X and Y here, and then you remove Y. That's exactly what I think I want to run, is I'm going to remove Nginx right now. I know it has Nginx run in a previous attempt. It is running right here. And this is our Web1 machine that I have up and running right now. It is running Nginx, I think. And yes, it is. So it will be a good verification of what I just told you, is that if you install X, which is going to be MySQL, and have Chef, create that thing here, you will have a MySQL server running and it will leave your Nginx alone. That is what I expect to see, but we'll see what actually happens. So we have managed to remove our cookbook references. So this one is gone. We have added this reference so that new cookbook has arrived. Now I want to plan for providing my root password for the database. I will use the password 123 as my database password. That's my intention. So I need to explicitly call out my intention in that folder here. Somewhere I need to spell out that, you know what, MySQL, when you set it up, you should use my password that I'm going to give you. That intention has to be clear. And that is called out like this. So what I'm going to do is use a Web1 that we have already. In a good practice, you should not muddy your machines like that. You should always create a separate machine and begin from ground zero, begin with just enough operating system. You have a very high chance of success. If you are creating a mess like I am going to do right now, I had Nginx running and then I remove its reference and then I'm going to add new reference and then muddy my machine setup, just reuse the Web1. This is a bad idea. I hope that part is clear to you. If you have a new project, just delete the machine, create a new one, much better idea. That is what is recommended. That's what is written down here as a separate node, Web2. But you don't have to, at least I'm not doing it this way. I am going to mess around just like Brian suggested. And that's fine. But in practice, in real life, in production, you begin from fresh machines. That's a much better idea. It's a good idea, recommended idea. Do that. So keep it separate machine. I'm going to just use the existing machine. And what that machine definition needs to do is provide a node JSON file that looks like this. So here is my node JSON that I would like to have in my web 2, but I'm using web 1. And there's a question in chat. Let's go read that. It's a question from Brian. Oh, he wanted to go. So that's no problem. If Brian is not here, there's no point doing this exercise, but that's fine. I'll still do it. So what I'm doing is this web 1, it had the web role. I'm going to remove all of that and put this new one in. And this is a shortcut method of without using a data bag reference. I'm just calling out these passwords right here as an override attribute. And that is what I'm going to, this is a shortcut to using a full-fledged data bag method. I'm embedding my passwords right in the body of the node definition itself. That way I'm overriding the default passwords that the MySQL cookbook assumes. Let's go see what I just said. I said MySQL cookbook assumes. So that basically translates to this cookbook, the MySQL cookbook, and you go to the source code, and in there you first of all match the version that you're dealing with. So go to the tag number 563 and 563. So that's the book we are looking at. Now in here, if you go to attributes and default, and here is the password chosen by default by the cookbook developers. They decided that they like the password, I like random passwords, for their default value. So if you don't choose an override attribute, this is going to be the password. I like random passwords is going to be the password for you if you happen to use the version 563 of the MySQL cookbook, because that's what the attributes are, default. And it says, I like random passwords is the password for the root user. Okay, you understand it. Having said, I'm going to override it. I'm going to say my root password should be 123. My replication password should be 456. And my Debian password should be 789. So 3 passwords I just chose. I can choose nil if I like. Like they have chosen. But I like password 123. So that's what I'm saving here as an override attribute right there. Having said that part, I will now invoke my run list, and in that run list, I will invoke a recipe, not the default one, but the server recipe. As you can see here in MySQL, the cookbook has recipes, and there are 3. In the MySQL recipes, there is a client recipe, there is a server recipe, there is no default recipe, and there is a server deprecated RB. So it's a deprecated recipe. We're not using deprecated. We have only 2 choices. Either you can set up the client software or you can set up the server software. 2 choices. I want to set up a server, by the way, as you already know, as we discussed. So therefore, I'm calling out the server recipe in the MySQL cookbook. And I'm overriding these passwords like that. So that is my definition for my web 1. I'm going to close this window and reuse an existing machine, which is a bad idea. I'm doing it just to answer Brian's question. And now we proceed. What I want to do is, I think I'm mostly done with the exercise. I just want to execute. So what I want to do in execution is that we're going to prepare a new node running 1404. And by the way, it says does not support 1604. So I have to create a new node. I mean, my node is, I think, 1604, if I remember right. So login, I think my machine is 16. So I have to break it and make it. Yeah, this is 1604 Ubuntu right there. So it is not going to work. It needs to be 1404. So I need to either way destroy this machine. So here we go. Destroy the machine. Where's the destruction button? Destroy. Destroy and say bye-bye. And then I create a new machine. Let's create a droplet. I'm going to do it properly like the exercise says. I'm selecting 1404, like this version. And then choose a $5 droplet and put it in San Francisco. Choose the ID RSA key pair, and I just one machine. I'll call it my web2. And then I create. When I'm creating web2, that machine gets ready in 55 seconds. I need to create a DNS entry. So I go to Cloudflare. Again, this DNS entry is not strictly necessary, but it's a great idea to have a machine by the name as opposed to its IP address. So here is my web2 coming up, DNS entry for web number 2. And there is no record, so I type it web2 and put in the IP address for that machine available from this location where I can get my IP address is copy and bring it here and paste it right there as web2 and add the record. Now I have a new web2 location available in my DNS system. I need to go back to my machine here and modify the file name here, web1, make it rename, call it web2. Now attempt a connection like SSH. Can I connect to you? I think I can, but I'm just cross-checking. Yes, I did. And I am connected. So I exit. Great. I am able to connect. I have a web2 node reference clearly mentioned, called out like this with password overrides provided. And I need to run my run list. How do I run my run list? I need to first thing first, prepare the machine and then cook it. Prepare and cook this machine. How do I do that? I need to run this command. In one command, I can just do a bootstrap, knife solo bootstrap. This bootstrap command is a combination command of prepare followed by cook. You already know that. So I'm going to just bootstrap this one and say, you know what, root at IP address. You can pass on IP address references like this. But now that we have a DNS entry for this, it's easier. So what I want to be able to do is grab this portion of the command, bring it here. And in the command line, we'll say, yeah, go to this web2, please. And then you prepare and then you cook. That's our expectation, right? We have called out our desire in our folder structure, and we are doing a remote execution on using the knife tool, which will basically make an SSH connection to the remote computer, install chef, run chef, and report success. Once the success is reported, we'll go back to the machine and check whether we have whatever we expect. So here, it's going to run now. As it runs, you will have the install action, the setup action, basically the first action, which is the prepare step, knife solo prepare here, prepare. And then knife solo cook, both back to back, one after the other, if it goes. So I'm going to click. So it will first thing do install chef, which is the prepare part of the step. And then after the prepare step, it will go and run chef. And when it runs chef, it will of course send your cookbooks and everything that you have in your kitchen, in your folder. It will send the whole thing, and then at the end, report success. The success expectations are that we have a MySQL server running with a root password showing that works with the password is 123. Not I like random passwords. That's the default password, by the way. So here it is doing those things. You can see that MySQL server is getting installed right now. Even before that, you can see that the books were updated. So the MySQL community cookbook, the MySQL cookbook was sent over. It is installing the MySQL package. It is then setting actions that we expect, which is, let me scroll a little bit and find out where it is setting up the passwords for us like we wanted to. And you can see those in the output here that we said that you should. So it will set those things for us. And here it is setting the root password for us right there. 123. And it set the password 123 again. So that's what has happened. We have MySQL server ready and reported success, and the action finished installing. We are still on our workstation. We are not remotely connected to anywhere. We are working here. We're just asking our knife command to go prepare and then cook. And then it did. Great. Now, I want to just go to that box, the Web2 box. And in here, I am in the Web2 box. I am expecting that this box is now a database server with my chosen password that I have chosen to be 123. So first thing first, I'll check whether you have MySQL server running. So how do I do that? Or rather, MySQL d dash version. That should show me the MySQL server installed. And then I will see if you have processes running with MySQL daemon in the background. So we grep for it and say MySQL, and we find it is running right here. MySQL daemon is running. Nice. But now I want to connect to the database and make sure that it is indeed accessible to me with a password that I chose, which is 123. So I will say MySQL client minus u, user is root, and minus p, the password is, I'm going to type the password. The password I'm going to type is 123 and enter. And here we go. We are connected to the database console. It says, welcome to the MySQL monitor and the server version and the trademark and all that. And here is the MySQL prompt. You can come out of this prompt by pressing Control D as in Delta. So it says bye. This is the MySQL way of saying goodbye. And then you're back to the console on that remote computer. And then you say exit to come out of that machine back to your local computer. And here you are. So we succeeded in doing our exercise. Our exercise was, that we began with, is that I will have a desire. The desire that I have is I will, in my cloud, I'll get a machine and make a database server out of it. And it needs to use my password for 123. I will choose, not somebody. I will choose. So I'll put my desire in form of a kitchen. The kitchen is basically that folder that I work with. And in that folder, we have a bunch of things, like cookbooks and, node and role and data bag and this and that, all that good stuff. And .chef folder and an encryption secret and bunch of things. We did not actually use all of this. We just discussed what these things are. All we used was a minimal set, the MySQL cookbook, and a local override of an attribute. Local override of attribute containing my password. That's simply what we did basically at the end. We examined all the components that go inside our kitchen where we express our desire, and here is the output. Here is the outcome. The outcome was exactly in line with what we expected the desire to be. And that's the outcome we got. We saw in this machine, we connected to the database console using this 123 password, and it worked. So what I will like to now do is see if we have anything else remaining in this. I think we just finished the whole thing. Yeah, there is a verification step going on, which I already verified that. So verification step, and then what else we have? Yeah, we're done. So that exercise is done. What I want to do now is pause for questions, help us understand if there are any missing items that we did not. And we will now go play with a little bit on Ansible next time. And then jump back to Chef to get a feel of, compare, contrast, where we can use this versus that, and what is best for you, and or rather, more importantly, what is best for your customer. That's how you think, and you practice and you apply. So right now we have completed an overview of what Chef can do for us. We use the Chef solo version. Next time we will not use this version, but the Chef client version, and operate it together with Chef server package. This package needs to be running on a box somewhere out in the cloud, and we'll use a ready-made box to begin with. And later on, we will have our own Chef server. Right now, we just use a ready-made solution for this piece. So ready-made solution is available. Ready-made solution for this Chef server is available already commercially. And for 5 nodes under management, it is free. So that is what I suggest that you get. It is free. Don't have to give a credit card. It's available here in this website, manage.chef.io, and you please set up an account. And that is the location. I'm going to paste it in Slack chat here. Oh, not here. Here. And then you log in, and I just have an account, so I just logged in. That's how it looks like. It's the view to a Chef server, the commercial view to a Chef server. That's what this thing is. So you can visually see things. Apparently, my account did not succeed logging in. Or it is slow or what? I'm just waiting. Oh, there it goes. It's logged in finally. And so that's what the Chef server looks like. And you will also create a server like this, Chef server ready-made account, ready-made for you. You will use it in this Chef server exercise, which is going to be the, after some Ansible work, we'll play with Ansible to understand how it works, how it behaves, how it helps us. And then jump to the Chef client, Chef server usage scenario, which is slightly different, conceptually very, very similar. And we will, so the action expected, get this free account on that website I just gave you. Don't have to give them a credit card. But remember that if you exceed the number of nodes used, we just use 1 node today. If you exceed number of nodes 5, they might give you a phone call or email you, hey, are you interested in buying? And so you can just tell them that we are doing an academic exercise, so they will go away. They will not bother you. They're good people. So no issues there from that perspective. The limitation you have to understand, it is up to 5 nodes in control. So we are just going to be like playing with 1 or 2, maybe 3 nodes, depending on what we do. With that understanding, I will pause recording. Where is the recording button? There we go. And listen for questions.
So Nilesh, this is Tammy. So
Hi.
when we set up that node that has MySQL and we have to have it ready with the root password, when we're done with that exercise, is it okay to go ahead and destroy that machine, or are we going to be building on it in any way?
I will answer. Very good question, by the way. Let me tell you a thumb rule of dealing with machines. The thumb rule is terminate.
Yes. I know you've mentioned that many times, but I want to make sure that that's still going to be the case for this.
Right. It's always, this is the answer, always, all the time.
Okay.
The answer is to terminate and begin from fresh. That's the answer. It becomes so easy to just start up the whole thing again by running one command, is that you have the whole solution built for you. It might take like 2 minutes, but then that's it. And so there is no point in keeping machines running unless you're actually doing something with it. So as soon as you're done, go kill it.
Okay. I just don't want to start creating all these machines and forget what I've done. You know what I mean? And forget to terminate.
Exactly. That is absolutely right. And therefore, remember that you need to be like a cowboy or maybe cowgirl and just shoot.
Sounds good to me. Thanks.
Terminate.
I just love that metaphor.
I do too.
You know what? That metaphor, you cannot use it in India because of religious reasons.
Right, of course.
You know, I thought about that when you said that too. I go, isn't the cow sacred in India?
Yes, cow is sacred. I don't follow religion, so I'm okay. But sometimes in the program, occasionally you will have Indian people in the program that actually are religious. So I just have to apologize. I'm going to use a U.S. Texas analogy, and just bear with me, so they understand it.
Hey, Nilesh, I got a question for you.
Yes, please.
Exposure to Puppet and Geppetto. Could you maybe put a little bit more out there that I can digest? I bombed the interview because use Puppet and Geppetto a lot. I'm like, well, why? And it's for deploying bare metals more than anything, right?
Right. The bare metal deployments you can do using the tool of your choice. It's literally up to you. So I want to understand your question a little bit better before I answer it. I did not quite get the Puppet versus.
Well, my question is, could you maybe put some more notes out somewhere on your site about Puppet and Geppetto so I could, be more prepared next time?
Hey, Puppet and
Geppetto.
what? Who?
Geppetto. I don't even know if I'm saying it right. The father. It's a component of the software. It's a component of Puppet.
No idea. I need to do a research. I have no idea what that thing is. So
yeah.
Hold on. Let's do a search.